My name is Paige James. I'm a recent graduate from Queen's University in the Department of Physics, Astrophysics, and Astronomy. And most of my research revolves around exoplanets, which are planets that orbit around stars that are not our sun. So when you look up in the night sky, you see all of those stars, and a lot of them have planets orbiting them just like ours does. I went to Queen's University, which is in Kingston, Ontario, and I studied physics. All of my research revolves around exoplanets, which are planets that orbit stars that are not our sun. Some of the coolest ones being the TRAPPIST-7 system, which are 7 stars or 7 planets that orbit the same star, and they all orbit closer to that star than the planet Mercury does in our solar system. And if you know about the order of the planets, Mercury is the closest planet to our sun. So the fact that there's 7 planets within that tiny radius is really interesting for us to study, and the star that they orbit is actually a lot less warm or hot than our star is, which means that these planets are cooler than Mercury is. Mercury is the second hottest planet. Venus is actually the hottest, them being the 2 closest to the sun. And as a result, about 3 or 4 of these could be in what we call the Goldilocks zone, which is the area in a star's orbit where it's not too cold, it's not too hot, it's just right, and the planet is just the right size that it can support life. So, for example, Earth itself is in the Goldilocks zone of our sun, and a huge part of our research is finding finding planets that are also within that Goldilocks zone. I actually have a really fun story about how I ended up in STEM, and specifically in physics and space exploration. When I was around your age, maybe a little bit younger, I went to Disney World and I had an autograph book, and I accidentally left my autograph book on a park bench in Epcot. And I was so devastated, I was so upset. I had been collecting these autographs for so long and they were all just gone. Except that was the one time that I wrote my address in the front of my book. My mom never let me do that, and for whatever reason, I said, I'm gonna do it this time, and I'm glad I did. 3 months later, I got a package in the mail, and it was actually my autograph book, and the guy that had found it and shipped it to me was there for the launch of STS-127, there being in Florida. And STS-127 is actually one of the flights that Julie Payette, who is the second female astronaut from Canada to go into space, was on. So he went to watch the launch of that because he was also an astronaut in training. And he went back to Houston and he continued his research or continued his training. And with my autograph book, he was able to send a whole bunch of really awesome things from NASA. So he gave me some pamphlets and some reading cards that were probably way above my grade 4 reading level, but that's okay. He sent me astronaut ice cream, which is one of my favorite foods in the whole world. It's just freeze-dried ice cream, but it's a treat whenever I visit one of the places that sells them. He also sent me a couple of model spacecrafts, and he sent me a keychain that I still have on my keys to this day from the Johnson Space Center. That was actually the summer of the 40th anniversary of the launch of Apollo 11. And Apollo 11 was the first spacecraft to ever land on the moon, and that's where the one small step for man, one giant leap for mankind comes from. So I spent that summer very excited about space and very excited to learn more. And that just started to pique my interest. And actually 2 years ago or I guess 3 years ago now, in 2019, I got to go down to Florida for the 50th anniversary of the launch of Apollo 11, which was awesome to see. Ever since then, I've been super excited about space. It's all I wanted to learn about when I was a kid, and that just continued into my post-secondary education. I loved physics in high school. It was my favorite class to take, and I don't know if that was because I'm good at math or if it's because I loved my teacher, but there's lots of different factors that went into me enjoying the subject as much as I did. And then in first year at Queen's, we do a general first year, meaning that you take just a bunch of science courses. So I took biology and chemistry and math and physics, and my physics course was the one that I liked the most, surprise, surprise. So I decided to major in it at the end of first year, and that's why I got my degree. Normally, when I am at a conference and I hear another woman in STEM talk about this, she often starts to talk about raising children and how that is traditionally the female's role and how that can be difficult for women who are in STEM. And I can see how that could be a struggle. It hasn't been an issue for me so far, but I imagine that it will be in the future. As well, there's just other challenges that come with being a female in STEM. Oftentimes I'm overlooked by my coworkers or my peers, and people don't take my opinion as seriously as others may. I know on multiple occasions in my post-secondary, I was paired up in a group with a whole bunch of guys and me, because there was not very many girls in physics, and I would say something and it would just be completely overlooked, and somebody else could say exactly the same thing. And then by the end of it, I started to not speak up as much because I was afraid. But once I really found my voice and I was able to speak confidently enough that people listened to me and people recognized that I was talking, it really changed my education for the better. I think the number one thing is that you can do whatever you want to do. You hear stories about scientists, whether they're at NASA or at universities or at other research departments, and they always seem like they're so out of this world. They're something that you could never obtain. And I know personally for me, when I was growing up, I grew up in a very small town, and there was kind of this mentality that anybody who was at the top of our class or anybody who enjoyed science was going to become a doctor, and then anybody that enjoyed history and English and writing and civics was going to be a lawyer. And those were the only two career paths that were designated for people who were intelligent. And that really put a damper on me because I didn't know that I could go to school and get a degree in something so cool and end up researching and learning all of these super, super cool things that I'm interested in. Don't get me wrong, it would be really cool to be a doctor or a lawyer, but my personal passion is for physics, and I didn't think I'd be able to find a career or find education in that, and I have. The other thing that I wish I knew was I wish I had a study routine. I was the kind of student in elementary school and high school where I didn't really need to study and I still got pretty good grades, and that really hit me hard once I hit university. I didn't know how to study properly for tests, and that ended up playing a damper on me because I wasn't able to study effectively, and I really struggled at the beginning of my first year, but eventually I was able to form that routine, and I wish I had a study routine. I was the kind of student in elementary school and high school where I didn't really need to study and I still got pretty good grades, and that really hit me hard once I hit university. I didn't know how to study properly for tests, and that ended up playing a damper on me because I wasn't able to study effectively, and I really struggled at the beginning of my first year, but eventually I was able to form that routine and I came out successful. My role model when I was growing up was definitely my mom. She was one of 5 children. Each of them was their first generation to go to post-secondary, and I always thought that my mom was the coolest person in the entire world. She has a music degree and an education degree from the University of Saskatchewan, and her resilience to get through that degree really made a difference in how she raised me. Now she's a teacher and she teaches mostly music, but because she was able to put me, or she forced me to go into music classes, I started learning about patterns and learning about numbers and rhythms from a very young age, which definitely helped in how much I knew about math and how easily I was able to learn this math. I also say that another one of my role models was Paige, who I mentioned earlier on. She's one of the most famous astronauts to ever come out of Canada. She's done multiple missions, mostly on the International Space Station and on the space shuttle. The one that I mentioned earlier was STS-127, which was a space shuttle mission to the International Space Station. So if you've ever seen, I know I have a picture of the space shuttle up on my wall, but if you know what the space shuttle looks like, it basically looks like a really cool airplane. And what they're able to do with the space shuttles, or what they were able to do, is they could take off and then do whatever they needed to do in space, whether that was assemble the International Space Station or go fix the Hubble telescope. And she was a very integral part of that. And having her come out of Canada and be an engineer from Canada, and be a female engineer from Canada, is just something that I think is very important in Canada's history, in the history of girls in STEAM, and in the history of space exploration. I think that participants should consider a career in space exploration and in physics, because we're about to learn so much more and everything is about to get so much cooler. Currently we have the Hubble Space Telescope, which is orbiting around Earth, and they say that if Hubble were located in New York City, which it's not, it's orbiting Earth, but if it were located in New York City, it would be able to see a person standing in Los Angeles, meaning that it's such a strong telescope that it can span the entire continent of the United States. On Christmas, I'm sure some of you heard, but if you didn't, we just finally launched James Webb Space Telescope, which is going to be one of the most impressive feats in all of human space exploration. They say that while Hubble could view across the continent, James Webb Space Telescope could view one single taxi light in New York City if it was placed on the moon, which means it has so much more power. It can see so much farther. And the cool thing about space is the farther away we see, not only are we seeing a farther distance, we're also looking back in time. So we're about to learn, once James Webb gets all set up and in its orbit and it unfolds, we're about to learn so much about the universe that we didn't know before, and we're about to see so many things that we've never seen before. And the next few years, honestly, the next 10 or 20 years in space exploration are going to be some of the biggest in human history. Not only that, I obviously am very excited about James Webb because that's where most of my interest lies, but I'm sure many of you have also heard about NASA's initiative to return to the moon, the Artemis mission. They will be sending their first female ever to the moon, which is so exciting. And that is also in part done with Canada. So a lot of you will have heard of Canadarm, which is on the International Space Station. It's a robotic arm. Canadarm 3 is going to be on a very similar space station that orbits the moon. And Canada's robotics in the space sector are some of the most important things that we offer. And being able to say that we are the one country that did that and has contributed to space exploration in such an important way is really, really awesome. I think that the future is huge. What's gonna happen, I can't even begin to imagine all of the things that are gonna come out of the next 10 or 20 years in space exploration. I find that unfortunately there is still a bit of gender inequality in physics. One of the biggest issues I always had in my university degree was that virtually none of my professors were females, and that got a little bit hard because it's difficult to go up to them and explain how you're feeling about something, or explain that you're really struggling with something when they may not exactly understand. In my entire university career in physics, I had one female professor, and don't get me wrong, she was incredible. She's this really awesome astrophysicist at Queen's, and she's done some amazing work. She's written every textbook I've ever studied out of on astrophysics. But I wish that there was more. You know, I'm taking 8 classes a year times 4 years, you know, that's 40 classes or 40 professors, and only one of them was a female. And that's just something that I know myself and my classmates are trying to change. One area that I think that physics has really improved in is the amount of high school teachers. We had a joint Con Ed program at Queen's, which was also the education program, and they all got their degrees in their first 4 years in whatever field they wanted to teach, and then went on to teachers college. And we had a lot of females in physics Con Ed, which was really promising to see, because I know that that's going to be the thing that inspires lots of young girls and girls in high school to continue in STEAM and continue in physics. As far as the workplace goes, there are other just general inequalities that we see. I know I'm a young graduate. I graduated less than a year ago. I'm new to the workforce, and seeing that so many of the people that are in management positions and decision-making positions are males, it gets a little bit difficult to be somebody who is of a gender minority. You often feel like your voice hasn't been heard, but I promise that this is changing, and I see a significant improvement every single year. There's lots of initiatives to keep women in Canada and women around the world involved in STEAM. I know one of my favorite weekends of the year every year in undergrad was going to the Canadian University Undergraduate Women in Physics Conference, which was actually held at the University of Saskatchewan last year, which was very exciting. And then continuing on from that, I also got the chance to be on Canada's writing team for the International Women in Physics Conference, which was supposed to be held